Hello everyone, welcome to video lecture of ME312 Metrology and Instrumentation. I am Manu Joseph, Assistant Professor, Department of Mechanical Engineering, Rajgiri School of Engineering and Technology. Module number 6, lecture number 2, Temperature Measurement. In this lecture, we are going to discuss about liquid in glass thermometer, bimetallic strict thermometer, pressure thermometer, then thermocouple, its principle, application laws for thermocouples, thermocouple material and construction. So first, liquid in glass thermometer. So liquid in glass thermometer is familiar to you. The mercuric thermometer we are using at our home for temperature measurement is liquid in glass thermometer, where the liquid we are using is mercury. So the liquid in glass thermometer is the most popular and is widely used for temperature measurement. It comprises a bulb that contains a temperature sensing liquid, example mercury, preferably mercury, alcohol and pentane, which have lower freezing point than mercury and do not contaminate if the bulb is broken, are also used. That is, alcohol and pentane are also used. Since alcohol has a better expansion coefficient than mercury, it's also used. A graduated capillary tube is connected to the bulb. As we have seen in our thermometer, you can see a bulb at its bottom. So that is the basic component. It contains the mercury. And a graduated capillary tube is connected to the bulb. At the top of the capillary, a safety or expansion bulb is also provided. So a range cavity, so we can say range cavity here. A range cavity is provided just above the bulb to accommodate the range variation. The wall of the bulb should be very thin in order to facilitate quick transfer of heat. So this bulb, the wall of the bulb should be very thin to facilitate quick transfer of heat. For the response to be quick, the volume of liquid should be small. The larger the volume of the liquid, higher the sensitivity. For quick response, the volume of the liquid should be small, but for higher sensitivity, volume of the liquid should be larger. So there needs a compromise between sensitivity and response here for the case of liquid in glass thermometer. Liquid in glass thermometers are simple, portable and inexpensive. That is why common man is using this thermometer. They are fragile and not suitable for remote application and sensing surface temperature. Very easily breakable. It's breakable. It get easily broken. Under optimal condition, the accuracy of this type of thermometer is around 1 degree Celsius. Around 1 degree Celsius. So here we have a bulb and a capillary tube. At the top of the capillary tube, we can see that graduations are given. So when we keep this bulb in contact with the body whose temperature is to be measured, say 70 degrees. So the mercury will expand. Mercury will expand and give the temperature value based on this scale. The change in temperature can be measured using pressure thermometers. So here we are discussing about pressure thermometers. The change in temperature can be measured using pressure thermometers. These thermometers work on the principle of thermal expansion of the matter, wherein the change in temperature is to be measured. So when change is to be measured, so thermal expansion of the matter is the principle here. Temperature change can be determined using this thermometer, which rely on pressure measurement. We are relying on pressure measurement here. Depending upon the filler medium, pressure thermometer can be classified as liquid, gas or combination of liquid and its vapor. So that's about different types of pressure thermometer based on liquid, the material medium we are using. The pressure thermometer comprise the following component: a bulb filled with a liquid, that's the first component, vapor or gas based on this thermometer type, and a flexible capillary tube and a Bourdon tube. Since the pressure, there is a relation between pressure, you are reading pressure variations also with the temperature change. So that is why we are using a Bourdon tube here. Due to variation in the temperature, as we know, when the temperature varies, the volume and pressure of the gas will change. So the pressure and volume of the system changes, and the fluid either expand or contract depending upon the property of the fluid. This causes the Bourdon tube to move or uncoil. As we know, the pressure variation, when there is a pressure variation, the Bourdon tube will measure it. So it's Bourdon tube to move or uncoil, which activates the needle on the scale, thus providing the measure of the temperature. So based on the pressure variation, based on the pressure measurement, we are measuring the temperature here. So here we can see a bulb which contains certain liquid, vapor, or combination of liquid and vapor. Then we have a capillary tube and followed by a Bourdon tube with a scale or a needle with a linkage mechanism, gear mechanism. So when temperature varies here, when we keep a body in contact whose temperature is to be measured with this bulb, this liquid or gas, the pressure of this gas or liquid will changes, and as a result, this Bourdon tube will deflect, coil or uncoil, and it will move this needle so that we can measure the pressure. So pressure thermometers are extensively preferred because of the following advantage. Here direct reading or recording is possible since pressure thermometer give adequate force output. Here adequate force output we are getting, so we can get direct reading. We are not recording any other conversions. The pressure thermometers are less expensive than other systems. They show a superior dynamic response when compared to liquid in metal thermometer. They deliver high speed response. Their maintenance is easy too. They suffer from limited linearity and prone to output errors. Liquid in gas filled thermometers, the tube and filling are temperature sensitive, and if the calibration conditions differ along the tube, an error will be induced. So they are temperature sensitive. So the components of this system are temperature sensitive, so the chance of error due to temperature variation, calibration error. Okay, so but they deliver high speed of response and maintenance is easy. So that's about pressure thermometer. We can see a bulb, then a capillary tube. So that is same as that of liquid in gas thermometer, liquid in glass thermometer, but apart from that we have a Bourdon tube. Since the pressure variation is the principle behind this, we require a Bourdon tube. So that is about pressure thermometer. So till now we have discussed about two thermometers. One is liquid in glass thermometer and then pressure thermometer. Now we are moving to another type of thermometer, that is called bimetallic strip thermometer. Okay, so a bimetallic strip thermometer works on well-known principle that different metal expand and contract to a different degrees depending upon the coefficient of expansion of individual metal. So certain material will expand more compared to some other material when there is a temperature change, and this also depends upon the coefficient of thermal expansion alpha. Okay, for example, if two strips of two different metal, steel and copper, are firmly welded or riveted or braced together, that means they are constrained to move and subjected to temperature change, either cooling or heating, the degree of contraction or expansion of the metal differ depending on their coefficient of expansion. These two metal temperature coefficient different and expansion will be different. The metal strip tends to bend. The metal strip will always bend because they are constrained to move. So bend strip tends to bend only to a different coefficient of expansion. The contraction or expansion of the strip will be greater than the other. One of the strip will have greater contraction or expansion, so they will bend. So the difference in the expansion of two metal which make the strip bend is measure of temperature. That is, coefficient of temperature, thermal expansion varies with the temperature, not coefficient. The expansion with the temperature will varies with temperature, and it's also depending upon the temperature coefficient of expansion. When these two metals are joined together, bonded together, and brought to the area where temperature is to be measured, they will have different temperature coefficient of, they are having different temperature coefficient of expansion and will expand or contract in a different manner, causing the entire system to bend. Here, therefore, this deflection is a direct measurement of temperature. That's the principle of bimetallic thermometer. So bimetallic strips is manufactured in different shape, the cantilever type, platform, U-form, and helical and spiral shape. In bimetallic strip, the lateral displacement in both the metal due to its coil form, length of the bimetallic strip increases, which in turn increases its sensitivity. That is, in bimetallic strip, the lateral displacement in both the metal is much greater than the smaller, much larger than the small longitudinal expansion. The bimetallic strip thermometers are preferred for their ruggedness and availability in suitable form. They will be available in suitable form in the form of coil, helical or spiral shape, U-form, or cantilever type. These thermometers are used for sensing temperature of hot water pipe, hot vapor pipe, steam chambers, etc. They are used in temperature compensation clock and circuit breaker. So in circuit breakers, based on the temperature, we need to break the circuit. So this will be used here. Now we are moving to another important temperature measuring device, that's called thermocouple. Okay, so thermocouple, they are active sensors. Because they does not require any additional power source, secondary power source for the operation. We already studied about active and passive sensors. So thermocouple are active sensors employed for the measurement of temperature. The thermoelectric effect is the direct conversion of temperature difference to an electric voltage. So temperature change to electric voltage. So that's that is a transducer. So Thomas John Seebeck discovered that when two dissimilar metals are joined together to form two junctions, one junction is at a higher temperature than the other junction, so known as the cold junction. So one junction is at a higher temperature than the other junction, and that junction is called hot junction, and the temperature which is having lower temperature compared to the other junction, that's called cold junction or the reference junction. Cold junction will be taken as reference junction. A net EMF is generated. There. This EMF, which is also establishes the flow of current, can be measured using an instrument. So here we are considering the Seebeck effect. When the two junctions kept at different temperature, an EMF is generated. One will be a hot junction and other will be a cold junction or reference junction. So a net EMF is generated. This EMF, which is used for the measurement of temperature. The magnitude of EMF generated is a function of the junction temperature. It's always a function of the junction temperature. The magnitude of EMF generator is also depend on the material used to form the two junctions. So the EMF generator is a function of junction temperature and material used. So the thermocouple EMF is a result of combination of two different effects, the Peltier effect and Thomson effect. So we have seen the EMF generated in the thermocouple is a function of junction temperature and the material used two factors which are affecting the EMF generator. So then we have two different effects called Peltier effect and Thomson effect to explain the thermocouple EMF or thermoelectric EMF. We are going to study about this Peltier effect and Thomson effect. The French physicist Peltier discovered that if two dissimilar materials are connected to an external circuit in a way such that a current is drawn, they are connected together, two different dissimilar metals are connected together to form a junction such that they can draw a current. So it's a closed circuit which can draw a current. The EMF may be slightly altered owing to the phenomenon called Peltier effect. So then there is a EMF change. So in a nutshell, you can say a potential difference always exists between two dissimilar metals. Always a potential difference exists when two dissimilar metals are in contact with each other. This is known as Peltier effect. So two dissimilar materials when contact together, so then there is a potential difference. So that is a Peltier effect. Peltier effect. Okay. So the EMF generator is due to two different material forming a junction. Always there is a potential difference when we have a two different material joined together. So Thomson found out that the EMF at a junction undergoes an additional change. The EMF at these two dissimilar material junctions, there is an additional change due to the existence of temperature gradient along the either of both the metals. So when there is a temperature gradient, this EMF, the potential difference have an additional effect. That is the Thomson effect. Thomson found out. So Thomson effect states that even in a single metal, a potential gradient exists provided the temperature, there is a temperature gradient. So we have two factors which affect the potential. One is the material, dissimilar material and the extent of dissimilarity. So that is explained by Peltier, and the temperature gradient as a function. So the EMF generated is a function, or potential difference is a function of the temperature gradient that is defined by Thomson. So both these effects form the basis of thermocouple, which find its application in temperature measurement. Now both these effects form the base of thermocouple which find application in temperature measurement. The flow of current through circuit is spontaneous. It's spontaneous and it doesn't require any additional energy source. When two dissimilar metals are joined together to form a closed circuit, that is thermocouple, provided one junction is maintained at the temperature different from the other. This effect is known as, this entire effect can be called as Seebeck effect. We can see two dissimilar metal 1 and 2, material 1 and 2, they are connected together to form two junctions. One junction will be a hot junction with a higher temperature compared to this junction, higher junction compared to other junction. Therefore, due to two effects, one is Thomson effect and other one is Peltier effect. Thomson effect, when Peltier effect, dissimilar material are joined together, there is a change in the EMF, potential difference, and the Peltier effect, Thomson effect, when there is a temperature gradient along the metal, there is a EMF potential difference. So these two combine to form the effect of thermocouple or thermoelectric EMF variation, that is measured with the voltmeter. That is a direct relation with having a direct relation with the temperature variation. So here one of the junction we are keeping as here temperature measurement, one of the junction we are keeping as reference junction, and other one is the contact with the body whose temperature is to be measured. One is reference temperature and other we are contacting with the body whose temperature is to be measured. Okay, due to this variation, the EMF is generated, or that can be measured using voltmeter, and that is proportional to this junction temperature of the material, which is junction temperature or the temperature the body whose temperature is to be measured. That's the principle. So there are certain laws of thermocouple apart from Peltier and Thomson effect, which form the basis of thermoelectric EMF generator. 3 laws of thermocouple that governs the principle are required to be studied in order to understand their theory and applicability. They also provide some useful information on the temperature measurement of the information on the measurement of the temperature. First is law of homogeneous circuit. This law states that thermoelectric current cannot be sustained in a circuit of single homogeneous material, regardless of the variation in the cross section and by the application of heat alone. This law suggests that 2 dissimilar materials are required for the formation of any thermocouple circuit. So 2 dissimilar materials are required for thermocouple circuit. That's a law of homogeneous circuit. Then we have law of intermediate material or intermediate metal. If 2 intermediate metal is inserted into thermocouple circuit at any point, if we are introducing an intermediate material or circuit into a thermocouple, the net EMF will not be affected. The net EMF will not be affected provided 2 junctions are introduced by a third metal at identical temperature. So here we can see we are adding a 2 material M3, M1 and M2. Apart from that material M1 and M2, we are adding additional material M3. M1 and M2 additional, this is M1 and this is M2, additional material M3. According to this law, this additional material does not affect the EMF provided these 2 temperatures are same. This law allows the measurement of thermocouple or thermoelectric EMF by introducing a device in the circuit at any point without affecting the net EMF, provided that additional junctions introduced are all at same temperature. So we are adding a voltmeter to measure, so that will be created as an additional material, but that should not affect the temperature measurement. So their junctions created by 2 junctions created by this metal to this circuit will be having same temperature, then the EMF measured will be same and the temperature measurement will not be affected. That is the law. So law of intermediate temperature. If thermocouple circuit generate EMF E1 when its 2 junctions are at a temperature T1, that's the third law. That is, if a thermocouple circuit generates EMF E1 when 2 junctions are at a temperature T1 and T2. This is one circuit, temperature T1 and T2. So E1 is the EMF generated. T2 and T3, when T2 and T3 EMF generated is E2. There is another thermocouple. Okay, suppose if you are joining, if you have a circuit containing T1 and T3, here we have temperature T1 and T3 instead of T1 and T2 or T2 and T3. T1 and T3, the extreme temperature, then the EMF generated will be E1 plus E2, the sum of EMF of these 2. So that is law of intermediate temperature. This law pertains to the calibration of the thermocouple and is important for providing reference junction compensation. This law allows us to make corrections to the thermocouple reading when the reference junction temperature is different from temperature at which thermocouple was calibrated. Usually while preparing the calibration chart of thermocouple, the reference or cold junction temperature is taken to be equal to 0 degrees Celsius. However, in practical, the reference junction is seldom maintained at 0 degree. It is usually maintained at ambient condition. So it's seldom taken at 0 degree. It's usually maintained at ambient condition. Thus, with the help of the third law, the actual temperature can be determined by means of calibration chart. Okay. So generally, in theoretically, we are considering the reference temperature 0 degree, but in actual case, it's usually maintained ambient condition. Therefore, we can relate the EMF with the help of this law. With the help of calibration chart, we can calibrate the instrument. we can calibrate the instrument. So that is law of intermediate temperature. Law of intermediate temperature. Then, so we have discussed about three laws. The one is law of intermediate temperature, then law of intermediate metal, and law of homogeneous circuit. Three laws. Law of homogeneous circuit, law of intermediate metal. When two metals are introduced and their temperature are same at the junction, two junctions formed by this metal, then the EMF will not be affected. That's the law of intermediate metal. And law of intermediate temperature, we found that when we have thermocouple with the T1 and T2 are this junction temperature, and then we have a EMF E1, and we have another thermocouple with junction T2 and T3 where EMF generated E2. When we are forming when we have a thermocouple with temperature T1 and T3 of same material, same combination, material combination, then the EMF generation will be E1 and E2, that is the intermediate temperature, and this can be used for the temperature calibration or thermocouple calibration. Now thermocouple materials. Now thermocouple material, the last portion, thermocouple material is application system. Theoretically, any two different material can be used for thermocouple, as we have discussed in the previous class, in the previous slides. Any two different material can be used for forming a thermocouple. However, only few are suitable for temperature measurement application. Thermocouple materials are divided into base metal type and rare, noble or precious metal type. The platinum thermocouples are called noble thermocouple, and all other thermocouple belong to base metal type. In a reducing atmosphere, these thermocouples are used with protection. Here in the chart we can see different combination of thermocouple material. So copper and constantine and temperature range, iron and constantine, the chromel and constantine minus 200 to 1000 degrees. So chromel, aluminal material. So that is example for base metal type. They have different type also, T type, J type, E type, K type. Then we have rare metal type, S and R. They are platinum thermocouples. As we have seen, they are platinum thermocouple or noble or rare metal type. So another one, the material combination like tungsten, rhenium, iridium, tungsten and iridium these thermocouple are called special type of thermocouple and are used for high temperature range of 1500 to 2300 degree Celsius. So they are high temperature, it can be used for high temperature measurement. So the choice of thermocouple material is influenced by several factors. Different combinations of thermocouple material should be possess the following characteristics in order to be used for temperature measurement. Capable of producing reasonable linear temperature EMF relationship. There should be there is a reasonable linear temperature EMF relationship. Able to generate sufficient thermo EMF per degree temperature change to facilitate detection and measurement. So sufficient thermo EMF per degree temperature variation for detection and measurement. Capable of withstand persistent high temperature, rapid temperature variation and the effect of corrosive environments. Good sensitivity to record very small temperature variation. Very good reproducibility which enables easy replacement of thermocouple by similar one without any need of recalibration. Good calibration stability, economical. These factors, many of these factors need to be considered while selecting a material for thermocouple, and we found that there are different base metal type and rare metal type. So that's about the thermocouple materials. So there are certain advantages and disadvantages of thermocouple. Temperature can be measured over a wide range. Quick and good response can be obtained. So the disadvantage, they have a low sensitivity when compared to other temperature measuring devices like RTDs or thermistors. Calibration required because of the presence of some non-linearity, or some non-linearity is there. That's why. Okay, these are some advantages and disadvantages of thermocouples. Now we have another term called thermopiles. Thermopiles. An extension of thermocouple is known as thermopile. A thermopile comprises a number of thermocouples connected in series, wherein the hot junctions are arranged side by side or in a star formation. Number of thermocouples are arranged to form a star or in series. In such case, the total output is given by the sum of individual EMF. The advantage of combination thermocouple to form thermopile is that much more sensitivity or sensitive element is obtained. They become more sensitive. So by combining different thermocouple, different number of thermocouple, okay, that is thermopile. For example, sensitivity of 0.002 degrees Celsius at 1 milliwatt per degree Celsius can be achieved with a chromal constant thermopile containing 14 thermocouples. We are combining 14 thermocouples. If n identical thermocouples are combined to form the thermopile, then the total EMF will be n times the output of the single thermocouple. Here we can see 1, 2, 3, 4. Their junctions are combining together. Okay, one junction is T1 and other is T2. So they will be the sum of the EMF at different due to different one. So that is more sensitive to temperature variation. So that is about different type of temperature measuring devices like liquid in gas thermometer, liquid in glass thermometer, pressure thermometer, then bimetallic strip thermometers, then thermocouple. And we found that the thermocouple is based on the principle that when two junctions are made by two different material joined together, then when these two junctions are at a different temperature, then there is an EMF variation. That principle is used. The one of the junction, the cold junction, is considered as the reference junction. Here is taken as the reference junction, then maybe by known temperature, and other junction will be considered as the body whose temperature is to be measured. Then there is EMF variation. The EMF will be generated that can be measured, and that is directly proportional to the temperature of the body, temperature difference. So thereby we can measure the temperature. So that is the principle of a thermocouple. So we studied about these things, and in the next lecture we will be discussing about the temperature measurement with some other devices like thermistors, RTD, and temperature measurement by non-contact methods. Okay, so that's about this lecture. Thank you.